Hello everyone, we are from Group 5 of Data Structures and Algorithms course of Sampurna University 2022, and our group consists of Ashley Brittany Hendrawan, Aureli Nathania Augustin, Destin Lee, Orzia Satifah Ilham, Kumara Evan Janatama, and me, Ryu Fatali Fadiaksa Putra Supeno. And in this video, we will demonstrate to you our final project for the course, which is the College Course Administration System. Let us begin.
Right. So what you see on the screen is the C++ code for our final project. And in our code, we have already implemented a header file, a .cpp file to correspond to the header file, and nonetheless, the main.cpp file. The reason why we use a header file is to make our code more neater and more tidier, because a header file is capable of implementing a class for CPP. And as you can see here, we have named our class Course Administration, and here are the public and private files of the class. And on the .cpp file, we can already see the objects of the class. The object name is previous semester, and it's based on the Course Administration class in a void data type, for example. Therefore, we have already filled one of the criteria for the final project, which is to implement a class and create it in a class format. Now, before we run the code, I would like to give a little premise about what our code is about. So, the College Course Administration System is a program where the university staff can be able to see the courses the student has taken in the previous semester, calculate the score, the GPA of each courses that the student taken in the previous semester, and nonetheless see and control the courses that the student wants to take in the future. In a way, for Sampurna University, we can think of this as the administration system the SPAC staff uses for the students. So let us run the code. Now, as you can see here, the College Course Administration System will first ask, firstly, of course, the student's name, because we need the identity, the data. So let's just input the student's name as I in first person perspective. And after that, the administration system will then ask how many courses had the student taken previously, how many courses had the student taken in the previous semester. And let's just say in the previous semester, the student has taken 4 courses. And after we've answered that part, it will then print out the list of lessons that is provided in the previous semester for the student, the list of courses, and nonetheless the number of credits for each courses. So let us begin inputting the courses. Let's just say one of the courses that the student has taken before is, as the name suggests, Data Structures and Algorithms, or DSA. Now, after we input the courses, one of the courses, it will then ask for the score for that courses. And let's just say that student got a 90. And therefore, it will print out the grade point. The formula for grade point is the score, which is 90, divided by 100 times 4, therefore returning the GPA value for the course. In a way, 90 divided by 100 times 4, we will get a GPA of 3.6. And after that, it will then be multiplied by the number of credits that course has. For DSA, it was 4 credits, so 3.6 multiplied by 4, we get a grade point for 14.4. The reason why we use grade point is to determine the cumulative GPA, which will be shown later. Now let's implement another course. And what if we input DSA again? It will ask us to input another lesson, another course, because DSA is already inputted. Therefore, it's error proof for this part. Now, let's just say another course that the student taken before was physics. And of course, the higher the credit, the higher the dependent determinant it is to decide how many GPA can they take in the next semester. So in a way, physics is important, the important score for the student to take. So let's just say the physics score for the student is, let's just say he or she got an 80. And now let's implement another course. Let's say the student has taken discrete mathematics before. And in discrete mathematics, let's just say his score is not satisfying. So let's just give it a 60. And now we implement the last course that the student has taken before. Let's just say previously the student has taken algorithm class. And his algorithm score is not as satisfying as expected to be. So let's just say he got a 70. And therefore, it will print out the student name, the cumulative GPA, and the maximum credits the student can take for the next semester. Now, to calculate the cumulative GPA, we will total the entire grade points for each courses divided by the total credits uh, for each courses. In this case, we got the essay 4 credits, and physics is 5 credits, 9 credits, and then discrete mathematics 9 plus 3 is 12 credits, and algorithm is 12 plus 3 equals to 15 credits. Therefore, the total grade point divided by 15 credits in total, we will get the cumulative GPA. And nonetheless, the cumulative GPA is calculated through a stack data structure or stack format.
So what exactly is stack? A stack is a linear data structure which follows a particular order in which the operations are performed. Their order might be in last in first out or first in last out. When you think about stack, think of them as Pringles chips, a factory of Pringles chips. The first Pringles you put will always be put in the bottom, and it will be stacked until it reaches the top. And therefore, when a customer buys Pringles, of course, the first chips they take is the one on the top or the one in the last, not the first one. So that is what a stack data structure is.
And now that you know what the stack data structure is about, it will basically stack the courses and calculate it in that order. So in that case, if we put data structures courses first, the data structures grade point will be totaled in the last. And therefore, it will start with the algorithm course because it will take out the algorithm's grade point first. And then after the algorithm course, it will then total 8.4 plus 7.2 for the discrete course because it's a stack data structure. Therefore, it's taking the last one that is out. Therefore, the second last out was some discrete, and it will follow and so on. And therefore, we will get the cumulative GPA, which is 3.07. And the maximum credits the student can take is 21. Uh, in most universities, um, some students cannot take 24 credits at all because let's just say their GPA was not satisfying enough to deserve getting 24 credits. Therefore, we've already put some conditions that if the score is not as satisfying, they will only get a certain amount of maximum credits. And if not a certain amount of maximum credits, the student will fail. Now, the maximum credits for the student to take is 21. So now let's start inputting the courses the student wants to take for the next semester. And realistically, the student would like to prioritize courses of the higher credits. Therefore, they can take that course without missing the chance. So we'll start with the highest credits. And let's just say the first one is object-oriented programming because it has 5 credits. And for the second course, we'll choose another one that has a high credit, which is chemistry, 4 credits, right? We choose number 5. And now we choose statistics, which has 4 credits too. And you notice that the total credits is changing because we've already added the courses and their respective credits. And now after statistics, let's just say the student wants to take macroeconomics. And lastly, the one that got his or her attention is mobile development. So we choose number 7. And as you can see, it will then lead to the student portal. In the student portal, the administration system can handle, manipulate, and control the student's courses. So let's just try choosing the first option, which is to print all the courses the student has chosen before. So if I choose option one, it will then print out all the courses the student has taken and nonetheless show the total credits the student has taken as a whole in total. And now let's sort the courses. And if you want to sort the courses alphabetically, we choose option three. So if we choose option three right here, the courses have been sorted alphabetically. This is before, and now this is after. It starts with C, M, and so on alphabetically. And now if we print the courses again, it will print out the courses that has already been alphabetized, that has already been sorted alphabetically. And let's just say the staff wants to remove or delete a certain course that the student has taken, maybe due to procedural reasons and so on. So we'll choose option two. And as you can see here, there are different keys to choose from. So let's just say the courses that the staff wants to remove is mobile development. So he'll choose option three. And as you can see, mobile development is removed and the total credits has been decreased from 19 to 16. Therefore, it's already been deleted. And now let's submit the courses. And now after ICE courses have been submitted, the program will then ask whether the administrator or the staff wants to end the program or add another student. For this case, let's add another student. If we add another student, it will then repeat the process all over again. So let's just say the next student is Ryufa. And now how many courses had Ryufa taken previously? Let's just say he took more courses than expected, which was 5 courses. So let's just say he has taken the data structures and algorithms and his score is 90. And let's just say he also took discrete mathematics. Let's just say his score for discrete is 100. And for algebra, his score was 102. For algorithm, his score will be a 90. And lastly, for physics, which is the determinant part, let's just say he got an 80. Therefore, it will nonetheless again print out the student name, the cumulative GPA, and the maximum credits. And for this case, Ryufat has satisfied the total GPA required to get a maximum credits of 24. Therefore, he can apply more courses than what I would have done before, the previous student, I mean. So now let's choose the course for Ryufat. Let's just say we prioritize the higher credits again. So we choose one. And then we want chemistry, statistics, and now macroeconomics, principles of IS, and mobile development. And now let's print all the courses Rifaf has taken just to be sure. And as you can see, he has already taken object-oriented programming and so on. It's already been printed in the list. And now, lastly, one of the highlights of our program, what if we want to sort the courses not in alphabetical order, instead in post-order traversal?
And if you may ask what is a tree is a nonlinear data structure and a hierarchy consisting of a collection of nodes such that each node of the tree stores a value and a list of references to other nodes, otherwise known as children. Additionally, tree data structures is a form of linked list data structures. Therefore, we have implemented a tree, a linked list, and a pointer for our final project. And what exactly is a post-order traversal tree? It is a tree method used to get the postfix expression of a tree following a left and right children policy or left to right children policy. So as you can see, it starts from the left from 4, the children number 4, node number 4, and then it goes to 2, and then when the left children is done, it goes to the right uh, children of the tree. Therefore, it goes to 7, 8, and then 5, and so on.
Now that you know what post-order traversal is, we will then try to sort the courses in post-order traversal. So if we click number 4, option 4, It will then print out the courses in post-order traversal. And now we also notice that there is some gaps between the post-order traversal sorting, as you can see from these dashes right here. Well, we really tried to improve this code, but even if we did, it's not really effective. Therefore, this is the best that we can do. But still it follows and applies to the post-order traversal sorting rule. So this is the courses before, and now this is the courses that is sorted in post-order traversal. And post-order traversal is, of course, the tree that is sorted based on a node and children, starting from the left, the most bottom left, to reaching the right after the left one has been sorted, the left node, the left children per se. And of course, since we've implemented the tree, therefore we have already filled a lot of criterias. We have already implemented a tree, a linked list, because to link the nodes, we will need to use a linked list. And therefore, to create a linked list, we will also need a pointer to store the data values. Therefore, we have already implemented three data structures all at once. And now what if I want to print the courses again? It will still print the courses that has already been sorted in post-order traversal. And now let's submit Refat's courses. And let's just say for now we want to end the program, not have another student. So let's just click option 2 and voila. As you can see, we've already done with our college course administration system. Now, while some improvements and some errors are to be expected and therefore needed to be proceeded to be fixed, we can all conclude that we have already built this program through hard work, teamwork, and dedication. Therefore, we really hope that you find our video interesting, and I hope this can inspire all your final projects in the future. We would also like to thank Mr. Rafi for guiding us, for teaching us, and for giving us advices for the final project. And that is all from us. That is all from me. We hope you enjoy the video.